Hello and welcome back to a video series on MAC 1140 Precalculus Algebra. My name is Sean Perry. These are guided notes number 29 in the series, Final Exam Review, Part 3. Question number 42 just wants us to evaluate the binomial coefficient 13 choose 12. The binomial coefficients appear in Pascal's triangle, and the one that we're being asked about is going to be one that's down this diagonal series of entries here. One might notice that along Pascal's triangle, we have all ones down the outer edge, and then 1, 2, 3, 4, 5, and so on down each one of these two slightly interior diagonals. This means that when we have something like 13 choose 12, we're really just going to get 13 back for that. We also have a formula for the binomial coefficients, right? It's 13 factorial over 12 factorial times 1 factorial. But writing 13 factorial as 13 times 12 factorial, the 12 factorials cancel, and we just get 13. What one can also do is use a calculator. You want to type in the n number first, and then go to Math, over to Prob, NCR. And we want 13 NCR 12, and that's going to give us 13. But from this, we could get any kind of binomial coefficients that we would like. There are many uses for the binomial coefficients, especially in terms of combinatorics. The binomial expansion formula gives us one use. If I want to expand 5x minus 6y to the power of 4, what I'm going to want to do is take advantage of the binomial expansion formula. It says that each one of my terms is going to have a particular kind of exponent. We'll have some first component to the n minus kth power, and then this other component b to the kth power itself. And we want to look at those from 0 to n as sort of the powers of a descend and the powers of b ascend. Notice that no matter what, those powers are going to sum to be n. But we also need a coefficient to go out front, and that's going to be precisely the coefficient n choose k. So notice in these expressions over here, I have a lot of repetition. I'm really just changing what the value of k is and then evaluating. So for example, 4 choose 0, that's 1. 5x to the 4th power, that gives me these two guys. And then negative 6y to the 0th power. Well, things to the 0th power which are not 0 are 1, and so that goes away. And doing this for each one of these, we have this resulting expansion. We need not do the whole thing if all we want is a particular coefficient, but we do need to figure out which value of k we're going to use. Now, for example, here, I am going to want the x to have a 3rd power, and to make sure that my n minus k is equal to 3, I want k to be equal to 2. So the expansion would have a bunch of other terms we're not interested in, and also 5 choose 2 times 2x to the 5 minus 2 times 3 to the 2. If we just evaluate all that, we're taking 3rd powers of 2 and of x. 5 choose 2 is 10, and 3 squared is 9. So we multiply all these together. 8 times 9 is 72, times 10 is 720, and that's our coefficient of x cubed. Question 45 gives us a recursive definition for a sequence. That's a definition using previous terms of the sequence to define the next term of a sequence. Starting at 1 and 2 for a1 and a2 respectively, we have a 3rd term equal to their sum, and then a 4th term equal to the a2 plus a3, that gives me 5, and then a 5th term, which would be a3 plus a4, which would give me 8. Question 46 is a question about arithmetic sequences. These have a common difference. We are adding the same thing each time to get to the next term, and we can see that that's going down by 3 from these negatives, and so we're really adding 3 each time to get to the next term. We identify the first term and the common difference, and then our arithmetic sequence can be written as such. Similarly here, they want to know which term in an arithmetic sequence gives me some particular value, and to do that, we want to plug in what we know into the standard form, and then solve for n itself. This will tell me which term in the sequence will have that value. So here I have 145 is equal to 1, our first term, plus n minus 1 times 3. And just solving this fairly simple linear equation, we get 49 for our value of n. Question 48 brings us back to a binomial theorem type question. So again, don't let the size of this daunt you. It really does have a lot of repetition to it. You can go through and see that each one of these terms looks exactly like the other one before it. It's just I'm increasing these little blue guys by 1 each time. And then we just want to patiently go in and evaluate each one of these. For example, what about this term? I have 5 choose 3 times 3x to the 5 minus 3 times negative 1 to the third power. That gives me a minus 1. This gives me a square on each of these. 5 choose 3 is also 10. And so this would wind up giving me negative 90x squared over all. We do that for each one of these terms, and we get our full expansion. Question 49 starts to get us into the conic sections. We should identify that this is in fact a parabola. We have an x squared while y is not. X squared means it's facing up or down, and this term being negative means it's going down. Our 4a term is equal to 20, so a is equal to 5, and this tells me how far away from my vertex my focus and directrix are. A quick sketch really helps me out, right? I know this opens down. I can see there is no minus h or minus k terms next to my x and y, and so we have an origin for our vertex. Going up by 5, I get my directrix line at y equals 5, and then going down by 5, we get our focus. Now remember, the parabola moves to enclose the focus. That's what tells me to go down by 5 to get this focus. That gives me these 2 points and this equation for the directrix. Question 50 kind of reverses things. They say we have a directrix here and a focus here. What is the equation for my parabola? And let's start with a sketch, right? We have a focus over here at some value, minus 3.5, minus 2. And then over here, we have the line x equals negative 8.5. This is a vertical line, and we're going to open away from that line to enclose the focus. This lets me know that it opens to the right. Now, also going straight from this point to the line, we can figure out that the halfway point must be where our vertex is. That's going to be at minus 6, minus 2. Negative 8.5 and negative 3.5 are 5 units apart from each other, which means that 2.5 is my value for a. If I go down by 2.5 from negative 3.5, or if I go up by 2.5 from negative 8.5, I get to minus 6. And it'll stay, because we're opening to the right, it's horizontal, it's going to stay, the focus and vertex are going to lie along this horizontal line. So that really does give us enough that we could go and write this down in standard form. 4 times 2.5 gives me 10, and our h and k were minus 6 and minus 2 respectively, which changes these signs to positive when we put it into standard form. If we wanted to plot some additional points, I think going along here is a good choice, right? If I go up by 5 units, that's 2 times a, or down by 2 times a, 5 units, I can get 2 other very nice points. Question 51 gives us a parabola in standard form. We need to, from here, encode the h, the k, to get our vertex. We need to see that it opens down, because we have a x who is squared and a negative coefficient here. And we need to get the value of a, which is going to be 4 times this guy here, so we find that a is 2. Putting this all together, we have a vertex at 1, 2, and if I go down by 2 units, we get our focus, and up by 2 units, I get a value on the directrix. It will be the horizontal line y equals 4, and that's that. Question 52 starts to get us into ellipses. They tell me we have a center at 0, 0, a focus at minus 2, 0, and a vertex at 6, 0. Well, let's plot the center first. That's the origin. A vertex is going to be over here at 6, 0. And then they gave us this focus at minus 2, 0, but we're also going to have one focus in between the center and our vertex. So what we get is this picture like this. And what we're looking for to get this in standard form is the value of b. Now, there is a Pythagorean relationship between AC, which is the distance to the focus here. This guy right here is C, and then B, half the length of the minor axis, the distance from the center to a co-vertex. These have a Pythagorean relationship because it forms a right triangle. Now we can get b squared just by taking the difference of a squared and c squared, and this tells me that b squared is 32. If all we want is the standard form of the equation, we don't need b, we just need b squared, and that's 32. To graph this, I would identify the vertices, co-vertices, and it's nice to put the center and the 2 foci on this graph as well. Question 53 is also about an ellipse. It gives us the 2 foci, and it tells us the length of the major axis. The value of a, the distance from the center to a vertex, is sort of like the radius if this is the diameter. It's like the biggest radius. And so this is going to be half of 12, or 6. We also know that our center will lie exactly halfway between these two, which tells us it's at 0, 0. It's the midpoint of the line segment connecting the two foci. And so the value of C is also 3, which is the distance from 0, 0 to one of these points here. From there, we can plug them into our Pythagorean type relationship to find the value of b squared, and that gives us our standard form. It also tells us the value of b so that we could graph this, although the value of b is going to be an irrational. Question 54, they want to know the equation given a certain center, a focus, and a vertex. Okay, so let's plot those things. It gives us HK, it gives us our value for A, it gives us a value for C, and in the usual way, we can find our value for B, and that, with the correct A and B, is going to be our standard form equation. Now, also remember that your A, whichever is larger here, the distance to the main vertex, that depends on the orientation of the ellipse. This one, we had a center, one of the vertices, same y level. That means this is a horizontally oriented ellipse. So we put that a value under the x squared term for this reason. Question 55 is getting us into hyperbolas. For these, remember that we want to find the center. Our distance a is going to be the distance to the vertices. And unlike the other conics that we've seen, our foci are actually farther away from the center than the vertices are. The vertices are going to be at these 2 points, and our centers are inside the sort of lobes of the hyperbola. And we also have these asymptotic features. One of the first things that we should probably do is calculate these asymptotes when we go to graph a hyperbola. So let's get all of these values, right? We're asked to basically get standard form from this graph. So what are we supposed to extract from it? Well, we're supposed to extract a center, that's at the origin. And the vertices, those have values of plus and minus 4, 0. That means a is going to be equal to 4. And our asymptotes, this is where we can find our value of b from, right? It's going to be the numerator of that slope. And we could see what the slope should be. If I go over 4, this tells me it goes up 5. So b must be equal to 5. And from that, if you liked it, you could find the location of the foci. They have another Pythagorean type relationship. And this tells me where C should be found. It's at plus and minus the square root of 41, 0. What we need to do is make sure we put A underneath X, because this is horizontally oriented, and the B squared term 25 here underneath our Y value. This one, we can see it has a vertical orientation. The Y term is positive. The X term is catching this negative sign here. And the center is going to be at minus 5, positive 4. And now, what are these two values down here tell me? They tell me A and B. They're going to be 3 and 2 respectively. And that tells me sort of how far I have to go in order to get from the center to a vertex. That's my A value. But notice that is actually a Y in this case. So if we're talking about slopes of the asymptotes, rise over run, that's going to be A over B as opposed to B over A from last time. So our equations of the asymptotes are going to look as such. And here I'm just going to leave them in point slope form. Here we're not quite in standard form yet, although we can see the orientation. If I have a negative sign on my y, this is going to be a positive sign on my x squared term here. This is horizontal orientation. And so we divide on both sides here by 196 to get this equal to 1 and put it in standard form. And that tells me my values of a and b. We can see that x has a 49 in the denominator, and so this is going to give me a equals 7. And my b is going to be 2, because we have a 4 in the denominator here. Now, because this is horizontally oriented and we can see the center, no h and k, so this is at 0, 0, we're going to want to go up and down. We're going to want to go left and right by 7 units to get to my vertices. And where are my foci? Well, we need the Pythagorean theorem to tell us that, right? And we get square root of 53. So my foci are also going along the same axis, right? Each of these hyperbolas has a axis of symmetry which cuts it in half, called the transverse axis, right? You can see that in the first one. The transverse axis is the x-axis here, right? So your vertices and your foci will both lie along that transverse axis. Since our A value is indicating how far we're going over, our B value is going to indicate how far we're going up. So we need to put this ratio B over A for our slopes of our asymptotes. We'll have a plus and a minus version of those slopes for our asymptotes as usual. Question 58 asks us to put this in standard form. We know it's a hyperbola right off the bat because of the opposing signs of the quadratic terms. What we can do is use completing the square to put this into standard form. So here I've regrouped things and left a little gap. And also I've taken the liberty of factoring out my 16 from these two x terms and a 36 from these two y terms. Now, what do I want to add to make them perfect squares? I want to add half of this middle term squared, which is 1, but really I've just added 1 times 16. So let's balance that over here. And here I want to take half of 8 and square it. That's going to give me 16. But I've really added negative 36 times 16, so let's put that over here. Now, when I add up all the terms on the right-hand side, I get 576. And to put this in standard form, I want to divide by 576 on both sides. As it were, that reduces to put a 36 in the denominator of my x minus 1 term, squared, and my 16 in the denominator of the y minus 4 term, squared. So what we have here are values of a being 6 and b being 4. But we can see that this is in the form x minus h squared over a squared minus y minus k squared over b squared equals 1. So this is our standard form of a hyperbola. Question 59 asks us a question about circles. It says, what's the equation of a circle that has a diameter with the following endpoints, which I've graphed right here. Now, in order to find the center of a circle, we really just want to find the midpoint of any diameter. That's easy to find. We just take the average of the x's, the average of the y's, and that will tell us the center of the circle. To find the radius, we want to take half of the distance. And what we find is that the distance here, which we can find using the distance formula, so 9 minus 5, that's 4 squared, 16, and then minus 3 minus 2, that's another 5, so we get 25, and 16 plus 25 is 41. The diameter has length square root of 41, and the radius will be half that. Your standard form for a circle looks a lot like the standard form for an ellipse, but instead of over a squared and b squared, both a squared and b squared are the same as r squared, so it's generally multiplied over to the other side and not set equal to 1. But it's still, I mean, if you were to take this and divide both sides by r squared, you'd get a nice way of seeing that a circle is just an ellipse. Okay, so then we just need to keep track of what h and k were, and that's going to give us our standard form of a circle. Question 60 is also going to be about ellipses. So we can see that we have a sum of these two squared x's and y's equal to 1. This is going to tell us it's an ellipse because this middle bit is positive. And we have a center. It's at 4 minus 3. We can see its orientation, right? Ellipses, A has to be the bigger one. So that's going to be A here. It tells us that A is 8 and B is 5. If we wanted to find then the vertices, we would go up and down by 8, and that gives us 4, 5, and 4 minus 11. If we wanted the co-vertices, we could go left and right by 5 and from the center, and that gives us minus 1, minus 3, and 9, minus 3. Just plotting some points here to give us a sketch. And the foci, if we wanted it, like we would need the Pythagorean relationship. Remember, for ellipses, that's a squared equals c squared plus b squared. So we can solve that for c and then go along its semi-major axis, which this is bigger under y, so that's going to be vertically oriented. So we go up and down by the square root of 39 from the center to find my values of c. Here's a more detailed graph of that ellipse with the points all shown in their spots. You can't really get a good one here because going to negative 11, it takes us really right off the edge of the map, but that's okay. I mean, we got a pretty good sketch going. All right, that's going to do it for this video. That concludes the final exam review, and so concludes the course. Thank you very much for your patience. Have a great day and good luck with your studies. I'll see you in the next class.